Today's objective is to write a linear equation when given 2 points by finding the slope and y-intercept. Let's begin. First of all linear equations can be written in this form. Y equals mx plus b. This is called slope-intercept form. Now the y, this is our dependent variable, and our x is our independent variable. But what does m represent, which is the coefficient of x? It's the slope. M is the slope. It comes from a Latin word modulate, which means to move, and that's how our numbers will move in a numerical pattern. But just think of m as slope. Now b is the y-intercept. I always tell my students b is the beginning value of the table or the beginning value on a graph. So think of that as your y-intercept. So if we are armed, or we can find the slope and the y-intercept, we can make this or write this equation. That's what we're going to do today. But we're going to do that when given just this information. So we're going to write an equation that goes through the coordinates 3, 1, and the second coordinates 8, negative 9. So these are 2 points on a grid. What we're going to do is we're going to do this first using a table. So what we're going to do is we know that 3 is married to 1 and 8 is married to negative 9. Everything else is blank. I don't know that. But what I can do is find the slope. I can find the slope by finding the change of x and the change of y and forming a ratio and calculate the slope. The change of x in math, a triangle, is used to represent change. So the change of x, or the run, is plus 5. 3 plus 5 is 8. Now the change of y, or the rise, 1 going down to negative 9, how much did we go down there? We went down 10, so that's negative 10. That'll be our delta y, our rise. Now a slope can be defined as a ratio of rise divided by run, our delta y divided by our delta x. So I'm just going to form a ratio and divide those. So negative 10 divided by 5 is negative 2. And that is our slope, which I can use to start filling in these gaps here. 1 minus 2 is negative 1, and negative 1 minus 2 is negative 3. And I can go down the line. You notice I just keep subtracting 2 until I get to that negative 9. But now I can work backwards to find my y-intercept. Remember, our y-intercept is our y value next door to that 0 for x. So if I'm subtracting 2 when I move forward, what would I do when I move backwards? Correct. It would be the opposite slope. I'm going to add 2. And 1 plus 2 is 3. And 3 plus 2 is 5. And then 5 plus 2 is 7. And I stop. So my y-intercept is 7. And I have enough information to write my equation. Y equals mx plus b. I'm going to take out the m and put the slope. Take out the b and put the y-intercept. Bam! There it is. Y equals negative 2x plus 7. Now, if I wanted to, I could have taken a shortcut. Instead of taking small steps, I could have taken a Neil Armstrong, giant leap for mankind. Notice I had 3 and 1 as a pair. I could have gone back 3 in the x to 0. But if I go back 3, that means I'm going to go back 3 negative 2's. Why go back 3 negative 2's? Because the slope is negative 2. And negative 3 times negative 2 is 6. And I could have said 1 plus 6 is 7. So that could have been a quick way to find out my y-intercept, which would have still given me y equals negative 2x plus 7. Now, I can graph these pairs on a grid. So the first one, 3, 1. I always start at the origin, and the first coordinate is telling me my horizontal location. If it's negative, I go left. If it's positive, I go right. So I walk all the way down to the 3 here. But I don't stop, because my next coordinate is my y coordinate, and that tells me my vertical location. If it's positive, I go up. If it's negative, I go down. And I'm going up, so I stop at 3, 1. My next one, I start in the middle, go to 8, and then I'm going to go down, plummet all the way to -9. Put a dot there. Now I'm going to connect these dots, and I have a line, which represents the data that we had at the table. Now, where does the line cross the y-axis? It crosses right there. I have an arrow. Bam! And what's the coordinates of that point? At 0, -7. Didn't we see that in the table? We did. When x was 0, y was 7. It's the same information. Instead of it being tabulated with some numbers, it's a picture on a graph. Now I can also figure out my slope by looking at this line. I'm going to take these 2 points and figure out the slope by the ratio rise divided by run. Now think of it as a water level. And I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I miscounted. Let me count this again. I'm going to go down 1. There it is. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I missed that first one right there. So I went down 10. That's my delta y. And that's what we saw in our table. Now I'm going to run across the x-axis. And I run 1, 2, 3, 4, 5. So my delta x is 5. So when I form my slope, it's the same data. It's going to be 10 divided by 5, which is -2. And so I have my slope, I have my y-intercept, and I can form my equation. Y equals -2x plus 7. So that is 2 different ways that I can write a linear equation if given 2 points on a line.